Hello friends, welcome in the next lecture of Calculus First, and we are discussing our second chapter, sequence. In the previous lecture we discussed the definition of limit of the sequence. So what is limit of the sequence? If x is a real number, is the limit of a sequence x is equal to xn, then we say that for every epsilon greater than 0 there exists a natural number k such that mod of xn minus x is less than epsilon for all n is greater than or equal to k. So it is very important definition, you have to keep in mind, we have to use it again and again in the problem. So after this, what we discuss? Convergence and divergence of the sequence. The sequence xn has a limit x, then we say that xn converges to x. And if sequence xn has not a limit, then we say that the sequence xn is divergent. And we discuss some theorems on this. In the today's lecture, we have to discuss some examples on the limit of the sequence. So our topic is examples on limit of the sequence. So we take first example, show that limit 1 upon n it is equal to 0 using definition of limit of sequence. Or this question can be asked, show that the sequence 1 upon n is converges to 0. That is, this question may be asked like this, that is the limit 1 upon n is equal to 0. Show that this or this sequence is converges to the 0. Okay, so we will prove this or solve the problem. How we show this? So first we take let xn is equal to 1 upon n. Xn is equal to 1 upon n, and then what we can say, what we have to prove? Our claim is what? Limit 1 upon n. Here always n tends to infinity. It is not given in the problem because in a sequence limit is n tends to infinity, it is equal to 0. So what it means? That is by the definition what we have to show, for every epsilon greater than 0 we want to find what we have to find, k belongs to the n, that is the natural number k, such that what we can say, that mod of xn minus 0, our x is 0 is less than epsilon for all k, n is greater than or equal to k. That is, we have to show this limit is 0, that means for every epsilon we want to find k, that is natural number k, such that what? This mod of xn minus 0 is less than epsilon for all n is greater than or equal to k. Okay, so consider. So what we consider, if k is, or what we can say, n is greater than or equal to k, then what happens? Mod of xn minus 0 it is equal to mod of xn minus 0, put the value of xn, it is 1 upon n minus 0. What should be this? This should be 1 upon n. N is natural number, therefore we can write this is n, and it is less than epsilon. We have to show this mod is less than epsilon. Therefore, what we can say that is mod of xn minus 0 is less than epsilon if, when it is possible, if 1 upon n is less than epsilon, and when 1 upon n is epsilon, if and only if, what we can say, n should be greater than 1 upon epsilon. N should be greater than 1 upon epsilon. So you are getting this. This is n greater than or equal to k. Now we need n greater than 1 upon epsilon. That means what? You can take k which is greater than 1 upon epsilon. Which is greater than 1 upon epsilon. Therefore what we can say? Therefore choose for every epsilon greater than 0, choose k greater than 1 upon epsilon. Okay, k greater than 1 upon epsilon, a natural number such that mod of xn minus 0 is less than epsilon for all n is greater than or equal to k, and therefore this is the definition of a limit sequence. Okay, and therefore we can say that limit xn n tends to infinity 1 upon n, or we can say that this is xn is equal to 0, that is limit n tends to infinity. What is xn? 1 upon n is equal to 0, and this limit is 0, therefore the sequence 1 upon n is convergent, verges to 0. Therefore this sequence is converges to 0. Very simple. Just we have to find the k. Just we have to find the natural number k. If you choose our k which is greater than 1 upon epsilon, a natural number such that mod of xn minus 0 is less than epsilon for all n greater than or equal to k. Okay. Again we have to take the next example. Second example, show that the limit of the sequence 1 upon n square plus 1 is 0, or we can say show that limit n tends to infinity 1 upon n square plus 1 is equal to 0, or this can be asked like this, show that the sequence 1 upon n square plus 1 is converges to 0. Okay. So in the similar manner we have to prove the limit of the sequence is 0. So what we have to first assume? Let 1 upon n square plus 1, this is nothing but our xn. This is nothing but our xn. Therefore what is our claim? What we have to prove? Limit n tends to infinity 1 upon n square plus 1, it is equal to 0. That is what? Limit n tends to infinity xn mod of, or xn, limit xn is equal to what? 0. Okay. So what we have to prove? That is for every epsilon greater than 0, what we have to find? We want to to find, what we want to find k, that is the natural number k such that what we can say, mod of xn minus 0 is less than epsilon for all n is greater than or equal to k. Okay, so what we can write here, consider again, if k is or n is greater than or equal to k, then what we can consider, mod of xn minus 0. So what is mod xn minus 0? It is 1 upon n square plus 1 minus 0. And what is equal? It is nothing but 1 upon n square plus 1. And it is positive. Therefore, it is 1 upon n square plus 1. And this should be less than 1 upon n square. And this should be less than what? 1 upon n. This should be less than 1 upon n. Therefore, what we can say, mod of xn minus 0 is less than epsilon if, when it is possible, if 1 upon n is less than epsilon. That is what? N is greater than 1 upon epsilon. Is it? Then again in the same above in example, that is, for every epsilon greater than 0, we choose our k in R or in N and k greater than 1 upon epsilon such that what we can say, such that mod of xn minus 0 is less than epsilon for all kn is greater than or equal to k. Is it? We have to take this k is greater than 1 upon epsilon. If we take k is equal to 1 upon epsilon, then this must be only strictly greater than. Okay, so, and what is this? This is nothing but the definition. Therefore, limit x n tends to infinity, xn is equal to what? This is x is equal to 0, that is limit n tends to infinity 1 upon n square plus 1, it is equal to what? 0. And therefore we can say that this sequence 1 upon n square plus 1 is convergent to 0. So in the similar way we can solve so many problems on the limit of the sequence. So we have to prove we have to solve the next example, that is, using the definition of a sequence, show that limit n tends to infinity 3n plus 2 upon n plus 1 is equal to 3. Now the limit is equal to 3. So again what we can do, let xn is equal to our 3n plus 2 upon n plus 1. So what we can prove, what we have to prove? To prove. So what we can say, limit n tends to infinity, limit of xn is equal to what? 3. That is what we have to prove. Use the definition. For every epsilon greater than 0, we want to find k belongs to the n such that what we can say, that such that mod of xn minus 3 is less than epsilon. This is our limit for all n is greater than or equal to k. So we have to find n, k, that is natural number k, such that what? Mod of xn minus 3 is less than epsilon for all n is greater than or equal to k. Okay. So what we can Consider here again in the similar way, consider if n is greater than or equal to k, then what we can say, mod of xn minus 3, it is equal to, so write down the value of xn, 3n plus 2 upon n plus 1 minus 3. Do simplification, what we can get, it is equal to what, 3n plus 2 minus 3 into n plus 1 upon n plus 1, or what we can write, it is equal to 3n plus 2 minus, just do simplified, 3n minus 3 upon n plus 1, and what should be this? This is equal to, this 3 and 3 and get cancelled, minus 1 upon n plus 1, and what is it? It is equal to, it is equal to 1 upon n plus 1, and what we can write, this is strictly less than 1 upon n. Therefore, what we can write here, therefore mod of xn minus 3 is less than epsilon if, when it is possible, if 1 upon n is less than epsilon, and if and only if it is n is greater than 1 upon epsilon. Again same k we are getting. Thus if we choose k is greater than 1 upon epsilon, we get what? Mod of xn minus 3 is less than epsilon for all n is greater than or equal to k, and therefore what we can say, that limit n tends to infinity, mod xn is equal to what? 3, and this is nothing but we can say that limit n tends to infinity, it is 3n plus 2 upon n plus 1 is less than or it is equal to 3. That is in the same way we have to solve all the problems. Now we will take one more problem, that is the using definition of a limit of a sequence, show that limit n tends to infinity, square root of n plus 1 minus square root of n is equal to 0. So again in the same way we write xn is equal to what? Square root of n plus 1 minus square root of n. Now we do the rationalization. So what we are getting? N plus 1 minus square root of n. What we are doing in the rationalization? Multiply and divide by the conjugate of this term. So it is what? Square root of n plus 1 plus square root of n upon square root of n plus 1 plus square root of n. Okay. So here is minus, so we have to take here in the rationalization plus. So what we can get here? This is nothing but our a minus b, a plus b, a minus b, a plus b. What is the formula? A minus b into a plus b. What is it? It is a square minus b square. So this is our a, this is our b. So this is our a, this is our b. So this is a square means what? Square root of n plus 1 square minus square root of n square upon denominator is n plus 1 plus square root of n. So do the square. Why this is? This is because of this. So this is square, do square n plus 1 minus n upon square root of n plus 1 plus square root of n, and this is equal to what? This n get cancelled. This is 1 upon square root of n plus 1 plus square root of n. So our xn is equal to, xn is nothing but our 1 upon square root of n plus 1 plus square root of n. That is just we do the simplification for this. Now what we have to prove? What we have to prove? What we have to prove? Limit of xn is equal to what? 0. Limit of xn is equal to 0. That means what we have to prove? That is for every epsilon greater than 0 we want to find. What we have to find? k belongs to the n such that what? Mod of xn minus 0 is less than epsilon for all n is greater than or equal to k. N is greater than or equal to k. Again, what we have to do? We have to consider if n is greater than or equal to k. Then what we have to get? Consider mod of xn minus 0. So it is equal to, put the value of xn, that is square root of n plus 1 plus square root of n minus 0, and it is equal to what? It is equal to just 1 upon square root of n plus 1 plus square root of n. Okay, this is equal to what? All the positive, therefore we can remove the mod here, and this is simply less than 1 upon square root of n. Thus what we can say that, therefore what we can say that mod of xn minus 0 is less than epsilon if, when it is possible, 1 upon square root of n is less than epsilon, and when it is possible, if n is greater than 1 upon epsilon square. This is n is greater than 1 upon epsilon square. Therefore, for every epsilon greater than 0, choose, what we have to choose? K is greater than 1 upon epsilon square in n such that what we can say that mod of xn minus 0 is less than epsilon for all n is greater than or equal to k. And therefore what we can say that, limit n tends to infinity xn is equal to 0, that is just we are getting our answer. Limit n tends to infinity square root of n plus 1 minus square root of n is equal to 0. So very simple problems, just you have to remind a definition again and again. So definition is very important. So do understand the concept of the limit definition of a sequence. Okay, so we will take some other problems in the practical lecture. Okay, so thank you very much.